see if this thing is working today. That's fun. Hey guys. All right. All right, guys. So the first couple, hopefully, not too evil. So if I do, here's my King Henry thingamajig. I want to go from hecto to deci. So I want to go 1, 2, 3. So just move the decimal. So what do you get there? 153. So if we had metric from when you were born, it would be so much easier to convert things. It'd be insane. But too bad for you guys. And for me. Millimeter to decameter. So this is decameter, so it'll always have DA instead of just D. So I want to go, how many steps? 4. Okay. And that direction, right? So it would become, what would you get? Good? Yeah, good. So you got to go 1, 2, 3, and then one more, so it'll be 0.0932. Kick ass. I can't even imagine being in a country that use metric and trying to learn our system. We try to make our system as difficult as it is to learn the English language. I think it's basically what we do. 2,198 grams of water. Water. So here's the thing. I kind of talked about this a little bit. Possibly, can't remember now. But one of the most important things in conversions is to figure out the path you're going to take. So if I want to go from grams to, oh, poor little dude. From grams to cubic decimeters, I could go this way and then down, but converting between higher power units is kind of strange. We're going to talk about that here in a minute. It'd be much easier to go from here to there, and then whatever this is my answer, because that's a direct translation. So if I have 2,198 grams, how many kilograms do I have? 1, 2, 3. How many kilograms do I have? My poor camera's neck is tripod. Come here. Oh. Say again. What are you guys away? Hello. So how many times you got to move it? 3. 1, 2, 3. So you get 2.198 kilograms, but kilograms are cubic decimeters. So then I'm done. So if the question would have been grams of water equals how many cubic meters, I would have taken that all the way down to here and then went this way. Do you guys follow? I mean, currently it's grams. Where can I go directly from grams? I can go to cubic centimeters, or I can go to kilograms, right? So that's why we went to kilograms, and then I can go directly there. If I wanted to end up in cubic meters, where would I want to go first? From grams to what? To get here.
Kilograms.
Yeah, well, no, not kilograms, but I want to go, thousands of kilograms, right? Tons. So I can go from here to there, then I can go straight back here. So it's just figuring out the path you're going to take. I almost never want to go between cubic or squared units because those work differently and it's really easy to make a mistake.
It's essentially the same process.
Yes, it is. And we'll talk about it, but it just adds another possible little layer where you can make a mistake. Yeah?
Why is it not 219.8? Because can't you just go from grams to decimeters?
No. Well, from grams, you have to go from grams to, you can go here. But I don't see how you go from here to there directly.
Half road.
Now, I think what you did was you went from there to there, and then you moved it back one, because from centi to deci is moving it over one, right?
Yeah.
Okay, good. So I totally agree with you. We might as well talk about this right now, because I think it leads into the next problem almost. So I agree with you that 1 cubic decimeter equals 10, get out of the cubic, 1 decimeter is 10 centimeters. Is that cool? 1 decimeter would be 10 centimeters. Do we get the fundamental idea that each one of these is made up of 10 of the next guy down? That's really why it's all based on 10. So if I break a kilometer into 10 equal pieces, each one of those pieces is a hectometer. If I break a hectometer in 10 equal pieces, so forth. If I take a foot and I break it into 12 equal pieces, each one of those pieces is an inch. You see, it works the same way. Our smaller units together make a bigger unit, or my bigger units chop down to make a smaller unit. Does that make sense? So, 1 decimeter, the bigger unit, chops into 10 parts that are each centimeter. So that's 10 centimeters. But 1 square decimeter, what would that look like? What's a square decimeter look like? You drew it, Jeff. But what's the sides? How big are the sides? What's the easiest way to draw a square decimeter square? It's the only way really to draw. It's going to be a square. You guys can do this. What's the area of the square? It's 1 square decimeter, right? How do you get area? How do you get area of any square? What do you do? Multiply the sides. What do you multiply itself to get 1? 1. It's crazy. So a square decimeter would be 1 decimeter by 1 decimeter. Is that cool? Yeah. Easiest way to make a square decimeter is put a decimeter by a decimeter. Now you could make a rectangle where this is 2 decimeters and this is half a decimeter. Doesn't that still make 1? You can do it. Come on. Yes. Yes. But screw that. I agree. Those of you who are thinking to yourselves, why, Jeff? I agree. But I just want to show you, of course there's other ways, but the simplest way is this. Now how does that help me? Because I know that every decimeter is 10 centimeters. You with me? Where did I lose you? How are we doing out there? What part of this you got to tell me the minute you're lost? Because this is going to become a big part of what you got to do.
Wouldn't that be 100 centimeters?
I love. Okay, so I'm getting caught up to you. That was 100 square. So 1 square decimeter is 100 square centimeters.
And 1 decimeter is
And 1 cubic decimeters is 1,000 cubic centimeters. So since we're talking about this, let's keep going with this. Stay with me now. Let's come back to the units we're used to. So if I had a foot by a foot, that is what? One square foot. I like it. I just want to see if some of you guys would talk. You guys are freaking me out. So that's 1 square foot. Now take how many square inches, and how big is a square inch? It's an inch by an inch. How many of those could have fit in here? How many could have fit here? 12 of them. How many could have fit there? 12 of them. So that's really the equivalent of just writing that equals 12 inches and 12 inches. That's saying that 12 inch, I can cut this into 12, I can cut this into 12. So the whole area could be cut into 144 square inches. How are you doing that? 1 inch, 1 inch. And I can do that 144 times. Holy shit.
Did you do it? So I really gotta visualize it, see it draw the inches.
No, you do it. I'll tell you how it's going. So this is going to be 144. Now, instead of drawing the picture, do you see what's going on? If I know that 1 foot is 12 inches, 1 square foot is 12 squared square inches. So what would 1 cubic foot be? 12 cubed cubic inches. Do you guys see that? That's exactly what happened here. If 1 is 10, then 1 cubed is 1,000 of these. All right, maybe. So, how many feet in a yard? 3 feet in a yard. So what's 1 square yard? Yard. Where am I at? Where am I from? Maybe. 9 square feet. 1 cubic yard would be 27 cubic feet. I mean, not a big deal. And why does it make sense? Because you could draw a square where each side would be 3, so of course the area would be 9. Or a cube where each side would be 3, so of course the volume would be 27. On one level, it's like, well, duh. Right? I'm not trying to make you feel bad if you didn't understand this before, but it's just you don't look at things like this very often. Right? This is how linear, square, and cubic units work. And fourth degree, if you wanted a fourth dimension, we won't do that. All right. I always say something like that and I throw people off. I'm sorry. Fourth dimension? What the hell? Okay, all right. So coming back to this, it's going to help us on a problem coming up. This next one real quick. If I want to end up in cubic centimeters, I'm really trying to hammer this home. I just erased my poor little thing. But if I want to end up in cubic centimeters, and I'm right now in deciliters, what do I really want to be in to get to cubic centimeters? What would take me directly to cubic centimeters? What kind of liters would take me directly to cubic? I want to be in cubic centimeters. What leads directly there? Milliliters. What do I got? Deciliters. That sucks. But do you see what am I doing right now? I'm trying to figure out what path I've got to take. I want to go from deciliters to what? What's my path? From deciliters to milliliters, and then I can go to cubic centimeters. That's the path. And very often I'll try to tell students you want to write that path down. That's what tells you what the hell to do. And on its own, it's easy to figure that out. And then once you've got it written down, it's easy to do the next step. But if you try to get to the answer directly, you're going to do something wrong. So how do I go from deciliters to milliliters? Deca to milli. 1, 2, 3, 4. Right? Is that cool? 4. Alright. So then that would be, where am I here? 1, 2, 3, 4. 270 milliliters. Is that by itself cool? From deca to milli, I want to go 4 places that way. Is that by itself cool? Is everybody cool with the King Henry? Oh my God, you guys are going to drive me insane. Alright, give me something. I know for some of you guys this is really, really easy maybe, and you're just like, I don't want to say anything, it's too easy. Give me something. So let me know if you're not cool with what just happened. Maybe not cool with what just happened. So again, if I have 0.27 deciliters, how many places do I have to move? 1, 2, 3, 4 in that direction. So 1, 2, 3, and then a 0. 270 milliliters. Now, why the hell did we do that? Because 270 milliliters would be how many cubic meters? Centimeters. Sorry. 270 of these would be 270 of these. Because every one of these is one of those. We don't trust that because we're not used to a conversion that's so damn easy. Every one of those is one. So I got 270, I got 270. 270 done. The problem was easier because I avoided this weirdness. This is not that big of a deal, especially when you see it. But again, I try to avoid adding places where I can make a mistake. And I think I'm pretty good with math. But I still won't go this way because I know I can make an easy mistake. Why do that to myself? So what about part E? How's that going to work now? 1 meter is how many centimeters? 100. I like it. So it's square meters. So I got to multiply by what?
Itself.
Not just 100, but what? So here I would multiply by 100 to get here. Here I got to multiply by what? Since it's square meters.
1,000?
Well, 100, 10,000, right? So 100 times 100. And the number of zeros, you just count them. How many zeros are in 100 times 100? 4 of them. So the answer is going to have 4 zeros. Right? Don't overthink that. Or plug in the old calculator. Right? You're allowed to use a calculator. It's not Math 88. I'm going to assume you could do this if I made you. So that's 10,000. So 9 square meters is 90,000 square centimeters. Maybe. So when you're going from yards to feet, you would multiply by what? How many feet in a yard? 3. So if I had 11 yards, that's how many feet? 33 feet. It's crazy. If I had 11 square yards, I'm not going to multiply by 3 to get the square feet, because now I'm squared. I'm going to multiply by 3 squared. So 11 times 9 is 99. That would be 99 square feet. Do you guys get that? No. So working with units, we know. 1 yard is 3 feet. So that means that 11 yards is 33 feet. Is that cool by itself? I like it. So one way to look at this is what I'm multiplying by depends on what dimension I'm in. So here I multiply by 3 if I just got length. If I got area, 1 square yard would be how many square feet? Well, each yard is 3. So how many square feet will this be? 9 square feet. 9 is 3 squared. So every unit conversion that you know.
Square that, basically.
Say again? Yes, that's it. That's it. The pictures they keep drawing are why that's true. But if I want to go cubic, I would cube 9. I would multiply by 27 instead. So what do we do here? Normally for meter to centimeter, I multiply by 100. Since it's squared, I multiply by 100 squared, which is 10,000. That's how I get 90,000. And if you want to, you can draw the picture. If you want to, and do it that way. But really, all you got to do is just like you just said, whatever unit, whatever dimensions I'm in, I do that same thing to the number I would use. If I'm in cubic units, I would cube the number I would normally use.
Sometimes I think you make things more complicated than they are.
You know why? I appreciate it. Because I try to tell you why things work. I could just tell you, do this, and then you wouldn't understand why, but you'd be able to do it. But that's a false sense of knowing. Right? Huh?
I'll do homework, and sometimes I'll be doing it. I know how to do it, but I'm not understanding. It's just kind of like mindlessly doing it.
Yeah. And I try to get you guys to go with me down the road to really understand why things work the way they do. So I've had students take me and they said, "Oh, my last teacher made this make more sense. He just told me multiply by 5 always." I'm like, "Why?" "I don't know. It just works." Well, that's shit. That's pure shit. Right? I'm so sick of teachers doing that. And then they hit me and they're like, "Oh, you suck. You don't explain things well." No, I'm the first person explaining anything to you. Right? Not necessarily. There's a lot of good teachers. I don't want to say all the other teachers are, but some of them don't do the greatest job of explaining. And then you don't get used to it. And when you first hit it, you're like, "What the hell's all this shit? Just tell me what to do." No, I'm never going to do that. Never. So I'm sorry if you want that. I'm never going to give it to you. Okay, but does it make sense now?
Yeah.
I like it. Cool. Yes.
For number, or for letter E, why do you have to go to deca to milli and then to centi?
Well, that was part D. Because it was decaliters.
Or for part E?
Yeah. So again, if I'm in, here's decaliters, right? Sorry, where am I? Decaliters. I want to go to cubic centimeters is where I want to end up. And what would take me straight to cubic centimeters? Milliliters would. If I knew the milliliters, it would take me straight to cubic centimeters. So for example, if you knew that you had 8 milliliters, how many cubic centimeters do you have? If there were 8 milliliters, how many cubic centimeters would that fill up? 8. Bam! So do you see how, if I only knew how many milliliters there were, I'd be done, essentially.
See, but I thought it was just moving the decimal place.
Yeah. So from decaliter to milliliter, it's just moving the decimal over. Totally.
So you can't just go from deca.
Oh, okay, all right.
To
I understand.
centimeters.
You ready?
Yeah.
You can't go liter to meter. You can't. You can't convert liters to meters. You cannot. You can convert liters to cubic centimeters and stuff, right? You with me? So, decaliter. So I agree. If I had 4 decameters, how would I convert that to, well, let's see. What do I want to say? Yeah. How would I convert that to centimeters? If I had 4 decameters, how many centimeters is that? Tell me.
What I'm understanding is that you just take it, you go like, okay, you need to move it to the centi.
Yes.
So you need to move it over 4 decimal places.
1, 2, 3, 4, exactly.
So it would be 4,000? Yeah,
40,000. 4 times, right? 4 times. 1, 2, 3. Oh, 3 times, yeah.
Oh, okay.
4,000. All right. I love it. And right now you're saying, Jeff, what the hell? You just did what I said to do. Why are we having trouble? Because this is meters to meters. Meters to meters are beautiful. I want decaliters to go to cubic centimeters. You can't just say, well, I have kilograms and I want to convert it to square deciliters. So I'll just move it. It's got to be the same thing you're measuring. You got to be measuring mass or volume or.
I think what you know how we're just moving back and forth, but the way you're doing it, we're moving back and forth with the same unit. Yeah, with meters and meters and liters and liters. But from this, we're switching it we're changing from liters to centimeters or different things. We're switching the units. That's why. It's not just simple back and forth.
All right, that's exactly what I said. But okay, if that makes more sense, the order of the words you put that in, I love it. That's all I care about. Does it make sense? You seem to be.
I'm understanding that it's a different measurement or a different type of measurement. That's why we have to.
Yeah. You can convert length to length all day long directly, but I cannot convert volume to volume like this because this is liters and that's cubic centimeter. They're different. They're not even measuring that. This is a cubic length, right? And this is a pure volume. There's no reason they should go directly to each other, right? That's why this thing exists. This tells me how to go from length to just pure volume. Like from cubic yards to so many gallons. They both measure volume, but one is using length, and the other one's just saying, no, this much stuff. Right? Okay. Alright. So what about this next one here? So this one, it's really, you can do this several different ways. But if you draw it, what's a square decameter look like?
Square.
I like it. How big are the sides?
1
1
decameter.
decameter, I like it. 1 decameter by 1 decameter would make a square decameter.
Yes.
Each of those decameters is how many decimeters?
100.
Yeah, 1 to 100. I love it. Every step is a step of 10, so it's a step of 100. So it's 100 decimeters.
Keeping it straight.
So what's the area now in decimeters? Well, 100, 00. So it's 10,000 again, right? You guys know that basic fact about when you multiply hundreds and tens and so forth, you just count the number of zeros, right? The answer is going to have 1, 2, 3, 4 zeros in it, right? 100 hundreds is 10,000, not just 1,000. 1,000 is 10 hundreds.
Isn't it just 100 times 100 though?
Totally. What's 10 times 100? What's 10 times 100?
1,000.
Wait, 1,000.
1,000, right?
Yes.
So what's 100 times 100? 10,000. Yeah. How many zeros? 1, 2, 3, 4. You got to trust me at some point. Listen and trust. 1, 2, 3, 4. Answer's going to have 1, 2, 3, 4. Kabam. All right, let that be nice. So if I said, what's 9,000 times 8 million?
72 a lot.
72. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, 6, 7, 8, 9, 9. There, you just count the zeros and
Is
put
that
them
last
in.
one a 0 or 1?
What do you think? Alright, moving on.
Well, wait, what's that number called? The 72. What's that?
What's the number
place on
72
it?
called?
Or no, what's that one called? How big is that? What's the name?
I'll let you work it out. Just put your, what's that?
Oh, that's a lot. It's a big one.
It's a lot.
It's a big game.
A lot.
72 a lot.
Alright, so this is 10,000 watts.
Yeah.
So if I said, how much larger is this than one of these, how many times larger is this? 10,000 times larger. I like it. I mean, that's straightforward. It's 10,000 of those bad boys. So it's 10,000 times bigger. And finally, let's see. Okay, good. So this is really important about what we were saying earlier about the path you want to take. What answer do I want? I want kilograms of water, right? Kilograms of water. So what would get me to kilograms of water? What measurements? Yeah. So I really want you to see. What sucks about this problem right now that they always warn you about for standardized tests, that's also going to happen with me and the book. The units are all different. So not only do you want to choose the right unit, you got to make them all the same freaking unit. Don't just start doing 1.3 times 0.03 times 4. It's not going to be anything. So I want to make them all, in this case, I want to make them all decimeters because cubic decimeters will take me directly to what I want. So that's the path. That's the idea of where do I want to end up? What's going to get me there? That's the idea you got to incorporate into converting. So this one's already decimeters. Right? So how many decimeters is 0.03 meters? How do you make it from meters to decimeters? Good, I like it. So you just got to step once to go to decimeters. So 1.3 decimeters by 0.3 decimeters. And 4 centimeters is how many decimeters? So again, now we're just doing King Henry, right? So 4 centimeters is how many decimeters? And you got to move back one, right? 0.4. So you move one step, but you got to go that way. You got to go the same way you got to go on the King Henry scale. You got to go that way. So when you multiply that all out, what do you get?
0.156 kilograms.
Well, let's see. Real quick, we get directly to cubic decimeters, right? And in case you didn't realize this, the reason it's cubic is because it's got 3 of them. Decimeter times decimeter times decimeter is freaking cubic decimeter, right? So I think sometimes I notice a student doesn't realize that the math actually works in the units too. And then every cubic decimeter is, where'd it go? Is a kilogram of water. So that's going to be 0.156 kilograms of water. It's done. I like it. So there's 2 things to realize from today's interesting side discussions. One is I'm always going to try to explain why things work. Secondly, you're not supposed to understand everything the first time you see it in this class, right? You've got to give yourself time, but also ask the questions. I love it. You got to ask the questions. I don't want to hear anybody ever smirk about somebody's question. All questions are valid.
Even his?
Well, we'll see. Look at me going against my own thing. All questions are valid.